This is my horse Flo. We used her as our physics project to show how velocity and momentum are used to jump over poles.
For the calculation portion of our project, we decided to calculate the forward momentum of Flo the horse as she jumped over the box as seen in the video. I decided to focus on the time when all 4 of her legs were off of the ground so I could find that delta t based on the video and estimate the distance that she would have jumped based on being there in person and estimating from the video. I used that distance and the delta t to find the velocity, and we found her velocity to be 12.5 meters per second in the instant when all 4 of her legs are off the ground. So then I used that velocity to calculate the forward momentum, and Flo is about 500 kilograms. So 500 kilograms going 12.5 meters per second. Her forward momentum would be 6,250 newtons times seconds.
As you can see in the upper left-hand section of the paper, there is a free body diagram for the instant of takeoff for Flo. There are 3 forces acting upon Flo at that moment in time. A normal force pointing upward, a weight force pointing downward, and the impulse pointing to the upper left. On the top right of the paper, there's a free body diagram for mid-flight. In Flo's mid-flight, the only force acting upon her is the weight force. As you can see on the bottom left of the paper, there is a free body diagram for Flo's instant of landing. There are 2 forces acting upon her in this moment, the normal force pointing upwards and the weight force pointing downwards.
Jumping a horse makes use of potential and kinetic energy. As the horse approaches a jump, it builds up speed or kinetic energy in order to send it over the fence. When the horse takes off, that kinetic energy that it built up along the way is then transferred into potential energy. And furthermore, what we know about Newton's third law tells us that when the horse jumps, the earth exerts the same force on the horse that the horse exerts on the earth. So this built up energy and the force that's being exerted then determines how far and how high the horse will travel as it combats the force of gravity acting upon it. Now, with conservation of energy in mind, we know that the amount of kinetic energy before the jump is going to be equal to the potential energy at the climax of the jump. Thank you.